See about the second method of compound gear train. That means where are more than one gears on the shaft, then the gear train is called compound gear train or compound gear train of the gear. Okay, simple gear train means the gears placed in single shaft. Here compound gear train means in single shaft you should have the more than one gears in single shaft, have more than one gear on single shaft. That means compound gear train. Here see the same shaft having two number of gears, so this is called as the compound gear train. The speed ratio, now we are going to see about the speed ratio of compound gear train means here relationship between gear 1 and gear 2. That means N1 divided by N2 into N3 divided by N4, and then its relationship between third and fifth gear. That means N5 divided by N6 equal to T2 divided by T1 into T4 divided by T1 into T4 divided by T3 and T6 divided by T5. It's here the N3 and N2 are placed on the same shaft, so it will be getting cancelled, and then N5 and N4 are same, so it will be getting cancelled. Now remaining N1 divided by N6 equal to T2 into T4 T4 into T6 divided by T1 into T3 into T5. Okay, because it will be difference of teeth are presented in the gear 1 or gear 2 or gear 4, gear 3 as well as the gear 5 and gear 6 have the difference between number of teeth. Okay, here the speed ratio of gear train and compound gear train for the speed ratio equal to speed, it's a ratio between speed ratio of first driver, so the speed ratio of the last driver of the follower. Okay, this the product of the number of teeth on the drivers and the product of the number of teeth on the drivers. The train value is the ratio between speed of the last driven or follower and speed of the first driven. Okay, and now see about what are the advantage of the compound gear train. Okay, what is the advantage of compound gear train compared with the simple gear train? Much larger speed reduction from the first shaft to the last shaft. This is the much larger speed reduction from first shaft to last shaft can be obtained with the small gears. Okay, the speed reduction can be achieved by the small gears by replacing the small gears. The simple gear train is used to give the large speed reduction at least gears have to be very large. Okay, usually for speed reduction in excess of 7 to 1, a simple gear train is not used and compound trains are warm gearing is employed. Okay, now see about the riveted gear trains. When axis of the first gears, that means first driver, when axis of first gears first driver and the last gear the last driven or follower are coaxial. That means here this is the gear 1, this is the gear 2, this is the gear 3, this is the gear 4, inside is the gear 4. It's nothing but the first gear and the last gear of is coaxial, is nothing but riveted. Okay, that means input and output is placed in the same axis, means it's a riveted gear train. When the axis of first gear and last gears are coaxial, then the train is known as the riveted gear train. Here is the first gear, this is the last gear, so these two gears are coaxial. So like this is the known as the riveted gear trains. Okay, now we are going to say in riveted gear trains the motion of the first gear and the last gears is like. Okay, that means the first gear and the last gear motion is same. Okay, that is a riveted gear train. Okay, now we are going to see about the speed ratio of riveted gear train. Okay, it's a ratio between number of teeth on drive-ons and number of teeth on drivers. Okay, is the relationship of n1 divided by n4 equal to t2 into t4 divided by t3 into t1 into t3. Okay, here the number of teeth on gear 2 into number of teeth on gear 4, because these are all equal number of teeth, and also divided by t1 into t3. Okay, for figure r1 plus r2 equal to r3 plus r4. Radius, that means r1 plus r2 is always equal to r3 plus r4. Okay, and t1 plus t2 equal to t3 plus t4. Okay, for figure, from this figure, here radius of r1 plus radius of r2 is always equal to the radius of r3 plus r4, like that number of teeth t1 plus t2 equal to t3 plus t4. This is the coaxial. Okay, here this is the input of gear, this is the output of gear, but both are coaxial. This is known as the riveted gear train. Now we are going to see about the epicyclic gear train. The epicyclic gear trains are axis of the shaft on which the gears are mounted by move relative to the fixed axis. Okay, for simple epicyclic gear train is shown in figure. A gear A, this is the gear A, and the arm C, this is the arm C, have a common axis. Okay, this is the arm, this is the gear A, gear A and arm O1 also the common axis. Okay, that means O1 about which we can rotate. Okay, we can rotate the gear 1, we can rotate about O1, and also arm on one end can also rotate about O1. Okay, the gear B meshes with gear A, this is the gear B, it will be meshes with the gear A, and is axis of arm at O2. Okay, is the axis of arm at O2, about which the gear B can be rotated. The gear B can be rotated about O1 as well as the axis of arm. Now if the arm is fixed, the gear train is simple, and gear A can be drive the gear B or vice versa. If arm is fixed, now see the if arm this arm C can be fixed, the gear A can be rotated, it will be drive the gear B. That means that here the gear B is the driven gear. Okay, but if the gear A is fixed, the arm is rotate about the axis of gear Y, but here the gear is fixed, but arm is rotate about the axis of O1. That means then the gear B is forced to rotate upon the around the gear A. Okay, that means if arm is if the gear A is fixed but the arm is rotate about the axis of A, the gear B can be forced to rotate over the gear A. Okay, around over the gear A. Such a motion is called, this motion is called the epicyclic motion. Okay, the gear trains arranged in such a manner that one or more their members have move upon around the another member. That means the one or more gears can move or rotate around the another one. That means the simply called as the epicyclic. The epicyclic gear train may be simple or compound. These are two types of gear trains, have simple or compound. Okay, now we are going to see the application of epicyclic gear train. The epicyclic gear trains are used in lathes, gears of back gears of the lathes, and differential gears of the automobiles, and also pulleys, blocks, wrist watches. This is the some application of the gear train. Okay.